Good day, everyone. This time we're going to discuss another type of conic section. So, if the plane intersects a cone and it is parallel to the axis of revolution or the y-axis, then you are forming another type of conic section, which is the hyperbola. So, what is hyperbola? Hyperbola, this is the set of all points x and y in a plane, wherein the difference of whose distances from two fixed points called foci is a constant. So the difference of the absolute value of distance 1 minus the distance 2 is a constant. So we have here an example of a graph of a hyperbola, wherein if you have noticed, we have focus 1, focus 2, we also have the vertices, this point here, the asymptote in the center. So you have to be reminded that A is the distance between the center to the vertex, while C is the distance from the center to one of the focus. Alright. Alright, so to understand more the definition of a hyperbola, here is an illustration. So you have 2 points, which are the foci on your hyperbola. So you have the first focus and the second focus. And if you're going to make a point on a hyperbola, let's call it point A. So the distance from point A to the second focus minus the distance from point A to the second focus is constant. Now, if you're going to draw another point on the hyperbola, let's going to call it point B. So the distance from point B to the first focus minus the distance from point B to the second focus is still constant. So whatever or how many points you're going to draw on the hyperbola, the difference is always constant. All right. Now, again, hyperbola, it is the set of all points in a plane such that the difference in distances of each point from two fixed points in the plane is constant. Now, do you still remember is the definition familiar to you? Very good. The definition of a hyperbola is like the same of an ellipse. However, the difference is that with the ellipse, you are talking with the sum of distances, while in hyperbola, you are talking with difference in distances. All right? So, they might somehow have the same definition, but however, the differences is that, again, for hyperbola, it's the difference. Well, for the ellipse, it is the sum. So, here, in the hyperbola, we have the different parts. So, the vertices, and this two here are the branches. And if you have noticed this line, the gray line, the gray broken line, these are called asymptotes. All right, now, the asymptotes are essential for determining the shape of any hyperbola. So, given the standard form, the asymptotes are lines passing through the center with the slope m equals positive negative b over a. So to easily sketch the asymptotes, we will be using two special line segments through the center using the a and b. So a and b. So that means you will be using the equation, no? The denominator rather. So given any hyperbola, the transverse axis is the line segment formed by its vertices. So the conjugate axis, this is the line segment through the center perpendicular to the transverse axis as shown in the figure. So you have here the conjugate axis and the transverse axis. So the rectangle defined by the transverse and conjugate axis, these are called the fundamental triangle. So this one, if you have noticed, we have here a gray rectangle. So this is what they call the fundamental rectangle. So this is are actually the framework, no? So the rectangle will help you decide um, the narrow or how narrow or wide your hyperbola is, no? So it is very useful with when graphing the hyperbola. So the lines through the corners of these rectangles have the slopes m equals positive negative b over a. These lines are the asymptotes that define the shape of the hyperbola. Therefore, given standard form, many of the properties of a hyperbola are actually apparent. So, next we have the components. So, just like the previous discussion we have with circles, ellipse, and parabola. So the hyperbola also has the following components. So the transverse axis. So how is your hyperbola presented? Is it horizontal or vertical? So it will always go down to the standard equation. So if the standard equation, if the positive falls with the x, so it is a horizontal hyperbola. If the positive value falls on the y, then it is a vertical. Um, the transverse axis is vertical. So still the center at HK. So, and then the foci, the vertices, the ends of conjugate axis, and your asymptotes. So to understand more the hyperbola, so we'll go to example number 1. So given that the equation of the hyperbola x squared over 9 minus y squared over 16 equals 1, we have to determine the transverse axis, the foci, the vertices, and equation of the asymptotes. After that, we're going to sketch the graph. So first is we have to consider what is the transverse axis. So if you're going to notice on the equation, our positive falls under x, no? So we have x squared over 9. So in this case, our transverse axis is actually, it is horizontal. Okay? So it is a horizontal. So we are going to identify our given. So we have here our a is 3. All right, our a is 3 because square root of 9 is 3. Our b is 4 because the square root of 16 is 4. So to solve for c, we'll be using the formula c squared equals a squared plus b squared. All right. So solving for c, you have 3 squared plus 4 squared is 9 plus 16. And c is equals to square root of 25, which is equivalent to 5. From here, we already know the value of our c. Now, it will be easy for us to determine the points on the hyperbola. So we have our center HK is at the origin 0, 0. So why it is in the origin? If you have noticed, we only have x squared here and y squared. So this will give you the idea that our center is at the origin or at 0, 0. Our vertices, so since our hyperbola, the transfer axis is horizontal, so for our vertices, we will be dealing with the equation quantity h plus minus ak. So our h is 0, our a is 3. So 0 plus 3 is 3, so we have 3, 0. 0 minus 3 is negative 3, so we have negative 3, 0. So for our foci, we will be using our c. So we have h plus minus ck, so 0 plus minus 5. So we have our foci or the following 5, 0 and negative 5, 0. And for our asymptote, so we will be using y equals plus minus b over a times quantity x minus h plus k. So you have to be reminded that if it is a horizontal hyperbola or if it opens to the left and right, your asymptote is b over a. So if the hyperbola opens upward or downward, your asymptote will be b over a. All right, so this is the only difference. So substituting the values of a and b, so the asymptote is y equals 4 over 3x and y equals negative 4 over 3x. Now we're going to graph our hyperbola. So to do that, diba, we have the fundamental rectangle. So we have to create the fundamental rectangle. So, or our framework. So how are we going to do that? So we're going to consider the denominator. So under the x, we have 9. So we have x squared equals 9. So therefore, x is equals to positive negative 3. So from the origin, we're going to count 3, positive 3, and negative 3. Alright, so this is our the beginning of our framework. Next is for the y, because we're going to create a rectangle, right? So for the y, will be under the y squared. So we have y squared equals 16. Therefore, y is equals to positive negative 4. So from the origin, we're going to count 4 units up and 4 units down. And there you have your framework. Right? So these intersecting lines, so this is our asymptote. Right? So this is our asymptote. So now we're going to plot our points. Vertices, the 3, 0 and negative 3, 0. So we have 3, 0 and negative 3, 0. And our foci, which is 5, 0 and negative 5, 0. Now in this case, it is now very easy for us to create our graph. Okay? So this is the graph for the equation x squared over 9 minus y squared over 16 equals 1. Alright? So next example. So example number 2. So given the equation of the hyperbola, quantity y minus 2 squared over 36 minus quantity x plus 1 squared over 9 equals 1. So determine the transverse axis, foci, vertices, and equation of the asymptotes, and then we're going to sketch the graph. So if you have noticed, our positive value falls under y, no, because y comes first before x. So the transverse axis is vertical. Very good. Because according to the standard equation. Alright? So to determine the points, the foci, the vertices in the equation, we're going to use the given. So we have our given A is 6 because the square root of 36 is 6. So the A is the first denominator. B is 3. So square root of 9 is 3. And we solve C using C squared equals A squared plus B squared. So substituting the values, we have 36 plus 9 is 45. And the square root of 45 can be simply written as 3 square root of 5. So if you have noticed here, we already have the value of our h and our k. Now, please do not confuse yourself. H is always with x and k is always with y. In that case, our center is at negative 1, positive 2. Negative 1, positive 2. So our vertices, so we have h, k plus minus a. So our h is negative 1, our k is 2, our a is 6. So negative 1, 2 plus minus 6. And to simplify, our vertices is at negative 1, 8 and negative 1, negative 4. For our foci, so we have h, k plus minus c. So we have negative 1, 2 plus minus 3 square root of 5. So it is represented with two foci, negative 1, 2 plus 3 square root of 5, and negative 1, 2 minus 3 square root of 5. And our asymptotes, so we have, again, since our positive value falls under y, so our asymptotes will be a over b. Okay? So it is now equal to y equals positive negative 2 times quantity x plus 1 plus 2. So now we're going to graph our equation. So again, we're going to make our fundamental rectangle or the framework. So we go through this. So falls under x, so we have 9. So we have x squared equals 9. So x is positive negative 3. So and for the y, so we have y squared equals 36. So y equals positive negative 30, positive negative 6. Now, if you have noticed, since our center doesn't lie on the origin, no, it lies at negative 1, 2. So negative 1, 2. So this is our center. So we're going to count 3 units to the left and to the right. So we have here, and the second one is here. And for y equals positive negative 6, so we're going to count 6 units upward. So 1, 2, 3, 4, 5, 6, and 6 units downward. So 1, 2, 3, 4, 5, 6. And there you have your framework. So you're going to draw your asymptote. All right. And we're going to plot the points, your vertices. So we have negative 1, 8, and negative 1, negative 4. And our foci, so 2 plus 3 square root of 5, this is approximately around 8.7. So we have the first foci is above this one, almost 9. And 2 minus 3 square root of 5 is around 4.6 something. So we have here the second point here. Now, we can now graph our hyperbola. All right. Okay? Okay. So, we have here the equation quantity x minus h squared all over a squared minus quantity y minus k squared all over b squared equals 1. Now, in this type of equation, the transverse axis is horizontal, or the hyperbola is opening left and right. Now, how will you know? All you have to do is to observe which of these two contains the positive value. So, if you have noticed here, the quantity x minus h squared all over a squared, this is positive, right? So, if the equation goes like this, you will have a hyperbola which opens to the left or opens to the right. Now, if you have an equation, quantity y minus k squared all over a squared minus quantity x minus h squared all over b squared equals 1, then the transverse axis is vertical. So, in this case, your hyperbola is opening upward or downward. All right.